2021 MCQ question number 5. Pause the video and read the question carefully before we start our discussion. This question is related with the mathematics we need for computing. So in our A-level syllabus, there is a separate lesson, dedicated lesson for the mathematical concepts we have to use, especially in computing. They are not very challenging mathematical concepts, but some very simple mathematical concepts are there. So in that lesson, there is a concept or an operation called the bitwise logical operations. We call it bitwise logical operations. So bitwise. So what is a bit? So bit is either 1 or 0. So this is a bit 1 or 0. Right? So why do you have something called a bit? So we know the modern computers are electronic computers. So there are electronic circuits inside these computers as well as any digital device such as the digital camera, digital wristwatches. There are circuits. These circuits are function on two states. What is it? The presence of the electricity and the absence of electricity. A circuit will be function depending on the presence of electricity or the absence of electricity. So the concept of the presence of electricity is taken as binary 1 here normally, and the absence of electricity is taken as binary 0. So thereby, when the computer scientists have to develop the computer programs, they use this concept of using bits. So they will use the bits or the bit streams, a combination of bits. So finally, these bit patterns will be converted to electronic pulses. For example, in a bit stream like this, there are 8 bits here, we call it a byte. So with this bit stream, each bit will be converted to an electrical pulse. Right? So 1 as, for example, 5 volts and 0 as 0 volts or minus volt, minus 5, something like that. So then what we see on a computer screen is in a human understandable form, right? So it may be a letter or a number or a special symbol or an image or a video or an audio. However, though we can understand what is presented to us on the screen, the computer will store all these things by converting them into the bit streams, 1s and 0s, right? So there are different circuits working in different ways. So we have to build up the circuits inside the computer finally. So there are very complex circuits inside the computer, and there are millions of circuits inside the modern computer. Sometimes billions of circuits will be there in the modern computer, right? So there is a bitwise logical operation. So for the bitwise logical operations, you need a bit stream. We usually take 2 bit streams. So let's take 1 bit stream here, 1, 2, 3, 4, 5, 6, 7, 8. So there is 1 bit stream with 8 bits. And to execute the bitwise logical operation, exclusive OR, so you need 2 bit streams. So we must have another bit stream. 1, let's take 1, 0, 1, 0, 1, 1, 0, 1, something like that. So you have a bit stream here, then another bit stream here. So normally a bitwise logical operation is carried out in this way. So you take these two bit streams in case of exclusive OR. This bit is evaluated with this bit. That means the first bit of this first bit stream is evaluated with the first bit of the second bit stream. And the second bit is evaluated with this one, third bit with this, fourth bit with this, and so on. Right? So then, how do you, so once you execute exclusive OR operation, so you will have a result here. So what is the result? So how do you execute exclusive OR? So here you take this bit and this bit together, and if these two bits are equal, that means 0 here, then if 0 is here, that is equal. Then let's say in this situation, now these two are equal, 0, 0. Here again, 1 and 1 equal, right? So that in this case, the first bits, so they are not equal. Then the result will be 1, 1, because they are not equal. So in other words, we say in two bit streams, in these two bits, an odd number of ones are available. If odd number of ones are available, the result will be 1. So in this case, odd number of, so there is only one. So a single one here, that means an odd number of ones. So, or in other words, not equal, 0, 1. So the result will be 1. So in this case, both are equal. So the result will be 0. Both equal, result 0. Both equal, result 0. 1 and 0 not equal, then the result will be 1. 0, 1 not equal, 1 result. 1, 0 not equal, 1. 1, 1 that is equal, then 0. So this is the final answer you get for the exclusive OR of executing exclusive OR for these two bit strings. So this may not be very interesting for a normal user, but for the computers, exclusive OR operation is very, very useful in some situations. So when we talk about something related with the syllabus itself, so in competency number 6, so we have 13 competencies in our syllabus. Competency number 6, so we call lesson number 6. It is the networking lesson. So we have to master about networking. So in networking lesson, we have to learn something called the cryptography. So what is meant by cryptography? So in communication, in networking, so you communicate a message from one place to another. Let's say A to B, you communicate something. So when you communicate something, a message, especially you have to think about the security. Why? Because sometimes we communicate or we transmit some sensitive data such as the bank account numbers and passwords, usernames. So when we transmit very sensitive information, so there is the possibility of stealing this information somewhere in the middle by someone like a hacker and using them for some harmful purpose, right? So to prevent that one, we have to use some techniques. One such technique is cryptography. In cryptography, we change the original message into a format that cannot be understood by a third party, right? So called the ciphertext. So in cryptography circuits, so you will have the exclusive OR circuits or gates there, right? And in the same lesson, again we have to use something called the parity bit. Lesson number 6. So parity bit is used to check. So when we transmit some, let's say a bit stream here, for example, 110, 1111, something like this. When you transmit this bit stream, at the receiving end, sometimes the bits transmitted may be flipped or changed. So 0 may become 1. 1 may become 0. Then it is not the original data that we sent from here. In other words, data will be corrupted. So the corrupted data will not generate the original message, right? So there are some techniques we use to prevent this one. So one simple technique is parity bit. By using the parity bit, we cannot prevent all kinds of errors, but to change to make a very simple check, we can use the parity. In parity bit also we use the what you call the exclusive OR. And again in lesson number 4, that is the logic circuits lesson. So we talk about adding or the addition of bits. Addition of bits. So for the addition, you really have to create the circuits inside the computer for the bit addition. Yeah. Right. So very simple circuit used to add 2 bits. So 2 bits. Very simple circuit we have to learn called the half adder. Half adder circuit. So to create the half adder circuit, again we use the exclusive OR, right? So the exclusive OR is very useful for the computers. So we have to learn it is with the basic mathematics we require for computing. With that understanding, we will go back to the question here. So you can see what is the output for the correct result of the exclusive operation with a given 2 bit streams. So there are 2 bit streams are given. So we will just write them on the board. You may be able to generate the answer by now. 0, 1, 0 first bit stream and 1, 1. So that is 1, 1, 1, 0, 0. 1, 1, 1, 0, 0. That is the first bit stream. And the second one is there are 5 ones at the beginning. 1, 1, 1, 1, 1. Then the last 3 bits 0, 0, 1. 0, 0, 1. So exclusive OR operation. So exclusive OR operation. So we have to evaluate each bit with the corresponding bit in the second stream. Right? So these are evaluated and you can see P not equal or odd number of ones. Then the answer is 1 here. And equal number of zeros there. So that both bits are equal. That is 0. Then not equal 1. Then equal 0. Equal 0. Not equal 1. Then equal 0. Not equal 1. So this bit stream is available in answer number 4. Answer number 4.